Good morning, dears. Today I am going to discuss some important concepts regarding sequence and series. In previous part, I have discussed about geometric mean and insertion of n geometric middle numbers between two numbers. Now, first of all, write some important points regarding geometric progression. First one, if we multiply each and every term, of a GP with some non-zero constant k not equal to 1, then the sequence so obtained is also a geometric progression. If we multiply each and every term of a GP with some non-zero constants and also not equal to 1, some non-zero constant k and also not equal to 1, then the sequence so obtained forms a GP. Point second, if we divide each and every term of a GP with some non-zero constant k also not equal to 1, then the sequence so obtained forms a GP. Third point, the product of corresponding terms of two GPs also forms a GP. Next one, the third one था the product of corresponding terms of two GPs also form a GP. Next one, the ratio of corresponding terms of two GPs also form a GP. The ratio of corresponding terms of two GPs also form a GP. ये चार बहुत इंपॉर्टेंट पॉइंट हैं जीपी के, जिनको आपको मेमोराइज रखना है. यू हैव टू मेमोराइज दिस. नाउ मूविंग अहेड, आई एम टेकिंग सम क्वेश्चंस रिगार्डिंग एपी एंड जीपी बोथ. How many terms of the GP, how many terms of the GP 3, 3 by 2, 3 by 4, and so on to be taken to give the sum 3069 upon 512. 3069 upon 512. How many terms of GP to be taken to give the sum 3069 upon 512? Solution. We have GP 3 by 2, 3 by 4, and so on. Let n terms to be taken are needed yet to be taken, जो भी लिखा जाए. So Sn is 3069 upon 512. Here A is 3, R is second term upon first term means 1 by 2. Sn का फार्मूला A 1 minus R to the power n whole upon 1 minus R equal 3069 upon 512. Substitute the values 3, 1 minus half to the power n whole upon 1 minus half equal 3069 upon 512. 1023. 1023. This will be 1 by 2. Go here. 1 minus 1 upon 2 to the power n is 1023 upon 512 into 1 by 2. Now 1 minus 1 upon 2 to the power n is 1023 upon 1024. This we have to take left side 1023 upon 1024, and this we have to take right side 1 upon 2 to the power 10. This becomes 1 upon 1024, 1 upon 2 to the power n. 2 to the power 6 is 64 and 7, 2 to the power 7 is 128, 8 power 256, 9 power 512, 10 power 1024. This is 1 upon 2 to the power 10 equal 1 upon 2 to the power n. This gives n equal 10. This gives n equal 10. Note it down. Moving ahead with one more question. If AR equal 1 plus 2 plus 3 plus and so on plus R whole upon R, then find the value of A1 square plus A2 square plus A3 square plus and so on plus AN square. Question is, if AR is 1 plus 2 plus 3 plus and so on plus R whole upon R, then find the value of this one. Solution, we have AR equal 1 plus 2 plus 3 plus and so on plus R whole upon R. That is R plus 1 by 2. R plus 1 by 2 upon R, then R. यहाँ पे R is cancelled with this R. This is R plus 1 by 2. Now A1 square means all putting value of R equal 1. 1 plus 1 2 by 2 यानी 1 by square 1. A2 square, substitute the value of R 2 plus 1 3 by 2 का square. This is 9 by 6 4 9 by 4. A3 square, substitute R equal 3 plus 1 4 by 2, that is 2 का square. This is 4. Now A4 square, 4 plus 1 5 by 2. 5 by 2 means 5 by 2 to the whole square. This is 25 by 4 and so on. An square. N plus 1 by 2 to the whole square. N plus 1 by 2 to the whole square. Now A1 square plus A2 square plus A3 square plus A4 square plus and so on plus AN square. This is 1 plus 9 by 4 plus 4 plus 25 by 4 plus and so on plus n plus 1 to the whole square by 4. So this is seeming like this. This is 4 by 4, 9 by 4, 16 by 4, 25 by 4, plus and so on, plus n plus 1 to the whole square by 4. Let this sum is Sn. Sum is Sn. So Sn is what? 1 by 4 taken as common. This is 2 square plus 3 square plus 4 square plus 5 square plus and so on plus n plus 1 to the whole square. If we add 1 square and subtract 1 square, this will be this is summation of squares of n plus 1 natural number, first n plus 1 natural numbers. This will be equal to n plus 1 n plus 2 2n plus 3 by 6 minus 1. This will be n plus 1 minus 1 by 4, n plus 1, n plus 2, 2n plus 3 minus 6 whole upon 24. Yes? Okay?
Yes, sir.
This can be 2n cube plus 15n square plus 7n plus 6 minus 6 whole upon 24, and taken as common n by 24, n square plus 15n plus 7, n square plus 15 and plus 7. Have you all noted? Okay, next moving ahead. Some special series. Some special series. First one, sum of first n natural numbers. You people know this very well. Sum of first n natural numbers. The sum of first n natural numbers is denoted by summation n. The sum of first n natural numbers is denoted by by summation n and defined as summation n equal 1 plus 2 plus 3 plus and so on plus n. This is n plus 1 by n plus 1 by 3. This is sum of first n natural numbers. This is the sum of first n natural numbers. यहाँ पे हमने sum of squares of first n natural number का फार्मूला अप्लाई किया है, n की जगह n plus 1 सब्स्टिट्यूट किया है। अब वो फार्मूला क्या है वो मैं अभी दिखा दे रहा हूँ जिससे ये चीज और क्लियर हो जाएगी। वो फार्मूला होता है n plus 1 2n plus 1 whole upon 6, n plus 1 2n plus 1 whole upon 6. So moving ahead, sum of squares of first n natural numbers. Second is sum of squares of first n natural numbers. The sum of squares of first n natural numbers is denoted by summation n square. इसे summation n square से रिप्रेजेंट करते हैं और summation n square is what? 1 square plus 2 square plus 3 square plus 4 square plus and so on plus n square. तो the sum of squares of first n natural numbers is denoted by summation n square and defined as summation n square equal 1 square plus 2 square plus 3 square plus and so on plus n square, and this is n plus 1 2n plus 1 whole upon 6. You guys are very much eager to know how it take this value. Are you eager? आप लोग उत्सुक हैं इसकी ये जानने के लिए कि कैसे ये इतनी वैल्यू आ रही है?
Yes.
Okay. Then I am going to elaborate this formula. We know. May I make it clean? May I make it clean?
Yes.
Yes, sir.
Okay, we know. What about we know? We know n plus 1 to the whole cube is what? N cube plus 3n square plus 3n plus 1. We know it very well. Yes, of course. N plus 1 to the whole cube minus n cube. This is 3n square plus 3n plus 1. On putting n equal 1, 2, 3, 4 and so on, n minus 1 तो फर्स्ट ऑफ ऑल n की वैल्यू 1 सब्स्टिट्यूट कीजिए, 1 प्लस 1 2 का क्यूब माइनस 1 का क्यूब 3 into 1 square plus 3 into 1 plus 1. When we substitute n equal to, it will be 3 cube minus twice cube 3 into 2 का square plus 3 into 2 plus 1. When we substitute 3, this will be 4 cube minus 3 cube 3 into 3 square plus 3 into 3 plus 1. When we substitute 4, this will be 5 cube minus 4 cube equal 3 into 4 square plus 3 into 4 plus 1, and so on, and so on. Now substitute n minus 1. तो n minus 1 plus 1 यानी n cube minus n minus 1 to the whole cube equal 3 n minus 1 to the whole square plus 3 n minus 1 plus 1. Now substitute n. While you substituting n, this will be n plus 1 to the cube minus n cube equal 3 of n square plus 3 of n plus 1. यानी n सब्स्टिट्यूट करेंगे तो यही चीज रहेगी. एडिंग अप ऐड कर दीजिए. देखिए 2 क्यूब माइनस 2 क्यूब कैंसिल, दिस कैंसिल आउट, दिस कैंसिल आउट, दिस कैंसिल आउट, सिमिलरली दिस कैंसिल आउट. What will be remain? Remain here n plus 1 to the whole cube minus 1 cube on adding. This will be 3 taken as common, 1 square plus 2 square plus 3 square plus 4 square plus and so on plus n minus 1 to the whole square plus n square plus 3 1 plus 2 plus 3 plus 4 plus and so on plus n minus 1 plus n plus 1 1 plus 1 plus 1 plus 1 plus and so on n times. See this? This is n plus 1 to the whole cube, n plus 1 to the whole cube minus 1 cube means 1 equal thrice. This is summation of n square. You can identify this easily. Sum of squares of first n natural numbers. This is summation of n square. This is summation of first n natural number, that is summation of n plus 1 plus 1 plus 1 plus 1 n times. This will be n. Now take this n left side, n plus 1 to the whole cube minus n minus 1 minus taken as common, n plus 1 equal 3 summation n square plus 3. This is n plus 1 by 2, n plus 1 by 2 summation of n. Now take this to the left side. This will be n plus 1 to the whole cube minus 3 by 2 n plus 1 minus n plus 1. This is thrice of summation n square. The thrice of summation n square, you can take n plus 1 as common, n plus 1. The remaining is n plus 1 to the whole square minus 3n by 2 minus 1. Simplify this. 3 summation n square n plus 1 taking LCM 2n square plus 4n plus 2 minus 3n minus 2। इसे हमने ओपन कर दिया और एलसीएम लिए थे तो 2 से मल्टीप्लाई कर दिया, तो n स्क्वायर प्लस 2n प्लस 1 2 से मल्टीप्लाई करके 2n स्क्वायर प्लस 4n प्लस 2 माइनस 3n और माइनस 1 2 जा 2 इज कैंसिल्ड विद दिस 2 3 डिवाइड में आ जाएगा, क्या हो जाएगा समेशन n स्क्वायर इज n प्लस 1 2n स्क्वायर प्लस n by 6 n taken as common summation n square this is n common n plus 1 2n plus 1 whole upon 6, this is the value of summation n square। Hopefully you got this, note it down। This formula I have used in previous problem. In place of n we have to substitute n plus 1. Okay, got it? Now moving ahead, sum of cubes of first n natural numbers. Sum of cubes of first n natural numbers. The sum of cubes of first n natural numbers is denoted by n summation n cube and defined as summation n cube equal 1 cube plus 2 cube plus 3 cube plus and so on plus n cube. This is n square n plus 1 to the whole square by 4. See this. This is n plus 1 by 2 to the whole square. n plus 1 by 2 to the whole square. Summation n cube is summation n to the whole square. Summation n to the whole square. Summation n cube is summation n to the whole square. You also eager to know how it take place. तो उसके लिए वही सिंपलेस्ट बात है कि n plus 1 to the whole power 4 आप अप्लाई कीजिए. This will be at the power 4 plus 4n cube plus 6n square plus 4n plus 1. और इस टर्म को लेफ्ट साइड ला करके वही n की वैल्यू 1 2 3 4 सब्स्टिट्यूट करके सॉल्व कर लीजिए. आपको इसकी वैल्यू पता चलेगी ये कैसे आई है. ठीक है. यू कैन इजीली गेट दिस वैल्यू. यू कैन इजीली गेट दिस वैल्यू. ओके, नोट इट डाउन. Hopefully you understand well about all these three special series. Sum of first n natural numbers, sum of squares of first n natural numbers, sum of cubes of first n natural numbers. We will meet with some important concepts in the next part. Till then, goodbye. Thank you.